you, Elena, very much. So I'll say a couple words before we start the presentation. So my name is Stefan Peev. I'm senior .NET developer at Ciklum. I'm with more than 5 years experience in the computer science field. I've been working with a wide variety of technologies, languages, and services. I'm a Microsoft certified developer, and my current interests, as you can see on the screen, are functional programming, cloud. Recently, I've tapped a little bit on the DevOps side. Very interested in CI/CD pipelines and automation of the deployment process. These are my current interests, and those are the topics I find very fascinating. As you can see in this talk is kind of touching a little bit of functional programming, as you will see. So this will be the agenda of my talk. There are 7 points. First of all, I'll present what is entity-related service, and I'd like to know if anybody has met some of those, is working with some of those, is designing one of those. What are the pros, the cons of these services, and how it stands against the solid principles. So we'll make a kind of point by point going through the solid principles and discuss how this stands against those principles, which of those it obeys or disobeys. Then we'll go through a couple of steps of refactoring, which will bring us to a CQS design approach, which stands for command and query segregation. It's kind of related to CQRS, but on a different scale. The pros and the cons of it, and again, we'll scale it against the solid principles, and then we'll have a large Q&A session where you can ask questions, and I'll try to answer them if I can. Also, if you have any questions whenever I'm speaking, you can write in the chat. I have the chat on my right side screen. So I'll be taking glimpses on the chat, and if I find the question relevant to the current thing or something it's not discussed or explained well enough, I'll try to explain it. Otherwise, all other questions would go on the end of the talk. So let's get right into it, I guess. So this is the whole refactoring we'll be doing. So we'll start off here. It's a practical presentation, and we'll go from point A to point Z. And it's a gradual step-by-step approach where you do a little bit step-by-step to improve your design in order to be more flexible, maintainable, but that comes with other costs, as you'll see later in the presentation. So entity-related services, this is the bottom, the start of the process. Then we'll split furthermore. Then we'll go into a CQS with casting, and this is just for an exercise. Then we'll go to the generics approach. We'll see how it behaves with the IOC container, how it can be registered, and what are the tricks there. And then we'll see the mediator pattern, which is the kind of, there are a bunch of libraries already developed which can be used to fulfill that whole design. All right, so let's start with what entity-related service is. Entity-related service is what I call is a service which represents whole functionalities regarding one entity in the system. Let's say we have a shopping website. We are selling products. So a product is an entity in our system. And this entity has to support a lot of functionalities. So let's say one functionality is whenever you want to add another product, you want to modify the description of an item. You want to modify what count of the item you have in store. You want to remove that item since it's out of stock or it's not produced anymore. And all those functionalities are kind of sealed in one class, and this class exposes all the functionalities regarding that entity. This is a brief explanation of the characteristics and how it looks on the abstraction level. It's basically one interface which provides all functionalities, as I said, for a product. And those are examples here. A product which could contain add product or CRUD operations and other operations along those. I block post service, and I'm pretty sure that every developer have already met this kind of approach whenever it comes to designing a system. One interface which is implemented by one class, and this class holds all the implementation details, all the functionalities in it. So it's a big interface and one big class standing behind it. So how does this look in code? So this will be our interface in our demonstration, and we have this iProduct service interface. As you can see, I've only had CRUD operations here. So I have list, get, create, edit, delete. Also, I want you to notice that here I have create, edit, and delete, not returning anything. For now, I forgot to say that the demonstration would be in C#.NET, but it applies to every programming languages. Doesn't matter what it is, if it's JavaScript, Python, Ruby, Java, whatever. The principles are still the same. Every object-oriented language could support this thing. So it's not big of a deal. It's on a conceptual level. It's not strictly related to C# or .NET or any specific technology. Basically, what's important for you to understand. Yeah, I'm reading the comments, but we'll see that. So here we have this interface, and then this is the implementation. Basically, the implementation doesn't do much. It only creates the object and pass it to the repository. I haven't added any business logic related to this. Yeah, and this repository stuff is another talk, since it's not the important part of the talk currently. I haven't added any business logic, so the class are tight and concise, so you can understand the idea, not the intricacies and the tiny bits of it. So this is the class implementing this interface, and some repository which will be persisting this whole class, whole object and database, or whatever store you're using is passed in. Nothing extraordinary. So this is what I call entity related service. One entity, we have one interface and one class implementing this interface. Somebody is saying that they can hear us and there is hearing echo or something. Do the rest of us hear us well?
Yep, I can hear well and no echo from me. Christy, please check your setup. Maybe something's wrong on your side. If not, we'll have bracket and it will have proper sound. We hope. So yeah,
All right.
no problem. Okay.
So basically, that's the idea behind entity-related service. Just out of curiosity, has anybody encountered this approach used somewhere? If you can write in the chat, and if you're using it currently, you can also write that in the chat. I'm wondering if this is all right. So somebody is using it. Yeah, because I think I've seen it a bunch of times before a couple of years. Currently, I haven't met it so often since the project are getting better and better. And yeah, so the projects and the expertise level is getting better and better, and people are managing their classes better. And so I guess that's why it's not very popular nowadays, or they're trying to get away from it and go to some flexible model instead of this. So that's the idea. Next, I'll be talking about how it behaves against changes, and this is basically how it stands against the solid principles. What are the pros, cons? So we have here, I've listed 3 factors how a feature is added in such a class, such a service. You basically go to the interface add method, then implement that method in the class. Simple as that. The only trick here is that your class might get quite large, since as you saw, I'm writing just a CRUD operations, just creation of the object is done in the service, and then it's passed to the repository. If the business logic grows large, you can basically understand that your methods will grow larger, and as the functionalities grow, your class might become hundreds of lines of code, if not thousands. How the change of a feature is done. So basically, you find the method you want to change, and you go to the implementation and change it. That could lead to side effects somewhere else in the code, so you have to be aware of this. Whenever you change something else might break. So your testing effort should be very, very good in order to track that dependency and what's the bug raised by the change and how feature is removed. You basically remove a class method and interface method. That's pretty much it. Here again, you have to track the dependencies of if this method is used somewhere else in the same class or in other service classes or whatnot, wherever it's used. You have to be aware of this and understand what would be messed up whenever you remove it. So in regards to testing, it's quite hard whenever you are writing test cases, unit tests, whatever tests you're writing against this big of a class. You have to consider a lot of things, since that service might have a lot of dependencies on other services, other cross-cutting concerns, whatnot, and you have to, for example, this iProduct service has to cache a memory cache on IDs, so it doesn't have to call the database every time it receives that ID. Whenever you're testing the write functionalities of it, say creating a product, then you have to mock that caching service you've injected, and you have to basically mock every service which is not relevant to the unit you're testing, to the method you're testing, and that's a bummer, since the test case are getting bigger and bigger. And whenever you introduce new features, say you want to enable auditing, you inject some audit service for whatever there is. Say whenever you create a product, you add a record, which is tracking, which is basically writing whenever a product is created, what product is created, and so forth. All test cases are breaking since you have to add this new dependency and mock it in all other unit tests, regardless of what you're testing, the listing of the products or getting product by ID. So this is one thing to consider. Testing it's a pain for those cases. Scalability, you can scale it, but you basically are getting yourself into the anti-pattern big ball of mud, where you create a service class which is so large that it's hard to navigate in it. It's hard to understand what's going on. I wonder if somebody have seen this big ball of muds, and even if somebody tried testing this kind of services, I'll be glad to see people have done this in order that they've been through this pain and understand what's the drawbacks of this and how it stands regarding modularity, not modular at all. So we can clearly state that basically this service it doesn't stand very well in regards to a solid principle, doesn't have single responsibility. It's hard to extend it. Interface, the interface is not segregated at all. Whenever we say we want to use this service somewhere else, where we need to only create a product, we're basically passing the whole interface, and we can use basically all functionalities which this interface provides, which might not be what we need. So it doesn't stand against solid very good. So let's get into a class diagram of it. Pretty much those are dependencies, and this is a decorator of the service. This is how would a cross-cutting concern will be added to a service like this. I mean, the good way of adding a cross-cutting concern, and this is audited product service. I'll switch really quickly here to the implementation of this thing so you can understand how it works. So basically you have another service which implements the same interface as the entity related service, and basically we'll be injecting the entity related service and pass throughing all the calls we don't need to add cross-cutting concern to it, and the other calls we do add whatever we want. Currently I'm just creating an activity item, and probably this could be logged somewhere in order to keep track of what has happened to a product. And as you can see, this is basically a clean approach of adding cross-cutting concern to this service, which wouldn't necessarily break your service. And this is the decorator pattern. I also wonder how many people have used it before, if it's popular in the programming community, since I find it very nice in those cases. So this decorator could be anything from caching, error handling, auditing in our case, whatever cross-cutting concern you encounter, you can do it this way. But whenever the class grows larger, as you can see, there will be a lot of those pass-through methods, or it depends if any method has to use this cross-cutting concern, then it will be even grosser. So this is a clean way to adding some cross-cutting concerns to those kind of services. And that's another reason I don't like him very much, since it's not very funny way to do that. All right, I think this approach is very easy to understand, and that's why it gains so much popularity in the community, and that's why it was so widely used a couple years ago. Probably some folks are using it currently also. And here, as I already said, are a couple of the pros of this approach. So low number of classes. Yeah, this audit whatever is just a decorator adding this feature here. So basically, whenever I create a product, then I create an activity entry, and here I haven't implemented where this activity would go. It could go in a Elasticsearch storage, can go whatever storage you'd like, just a activity tracker, what has happened to a product in our system. And that's done basically for create, delete, and edit, since I don't really care in my case to track an activity when a product is get by ID or products are listed. So the pros, low number of classes. As you saw in the diagram, we have so few classes. It's very easy to understand actually what's going on. They're not complex relations, abstractions, and so on and so forth. Very easy entry level. So any even junior developer could implement such a design and can go with it a long way. It's less complex since not a lot of connections between the classes. Basically, we have one interface and one class. That's it to it, and all in one place. Whenever that's more of a mental thing. Whenever you think of a product, you know where to find the functionality. It's getting annoying when the class gets larger and it's hard to navigate in 1,000 lines of code, on a couple of thousand lines of code. So that could go both ways. That could be worse or good, depends on how big the class is. And these are the cons, the downsides of such design. Increasing the maintenance effort proportionally as the size grows. So whenever you add functionality, your maintenance increases like progressively for every functionality, for every dependency you are adding to this class. It's getting harder and harder to maintain, since the code is getting tighter and tighter coupled to the things surrounding it. Then we have testing is hard and tedious, as I said. We've already said a lot of words regarding testing for this. Not easy to extend, since you have to add new method, or if you have to add a new dependency, that brings a whole new set of problems. If you want to add it through decorator, then the decorator becomes big. Could potentially become hundreds of lines of code. There's so much I can say on this side of the spectrum, on the con side of the spectrum. It's like, if somebody thinks about any other downside of such design, or even a good side, write it in the chat. We can consider it really quickly. It will be a pleasure for me. Or even if somebody joins and tells like, you forget about this pro and so on and so forth, I'll be glad. All right, I'll take the silence as you are supporting my idea. Yeah, for small projects, for sure. Small project POCs, that's the way you go. Whenever you start realizing that your project's gonna be large and will be involved in a lot of business logic and stuff, hard business logic, then you start considering, if you know that your project will be large from the get-go, then you better architect it so you don't have to refactor it. Since this refactoring we'll be doing in our demo here, it's not done for big projects for over the weekend. Probably could go even a year, or depends how big the project is. So it's not a small thing. And I've done it here, as you'll see in the demonstration, in a way so that basically the interfaces are not changed at all. So we are confident that the things are still working as expected, and we are not breaking things. But you'll see that when I start with the demo. And then that's the final thing we'll end up with. That's the use case specific services. For me, that's the way to go whenever you're developing a complex service with a lot of twisted functionalities and edge cases and so on and so forth. If you don't want to get into the cycle of if switches, if this condition happens, then do this, and else do that, and so on and so forth, which is annoying and hard to test and hard to follow as you wish. Okay, so first of all, what it is, what's use case specific service? It's basically the smallest thing which represent one use case of our system. So as a use case, I'm here referring to one specific action a user can do in our site. So for example, creating a product. Creating a product in our system is one use case of our system. So you can use the system to create a product. You can use the system to modify a product. You can use the system to change the quantity of available items, for example, and other functionalities. And every one of those is a use case. So that's why I call it use case specific. You implement around a use case, not around something else. So here the abstractions are, and those are the end game thing. That's when we boil down all the entity related service to use case specific. Those are the interfaces we'll be using. So first two are custom made. Those are what I will be demonstrating in the demo. And this one is provided by by a library called Mediator. Because I'm here trying to go to a little bit different route than what Mediator does, since I'm separating the models into read models and write models, where the write models are the commands. Those are all things which change the state of the system, say create product, modify product, remove product, and the requests are all the implementations of requesting some information from the system, all pure functions, and whoever is familiar with the functional programming. So those have side effects, those doesn't. And how the implementation is done. So we have implementation for every action we are doing. So create product command handler, get product query handler. That's my implementation. If you use Mediator, you probably tweak a little bit naming and stuff. But in my approach, those are the conventions I'm following. So command is mutation, query is pure function. And that's pretty much it. Has anybody used some of these things like command queries? Has anybody encountered designs like CQS, CQRS, have used mediator and all those patterns? I'm curious about how much of the people here in the call are into those things, and if they have any. So Rafael is saying that in every project he starts from scratch. He rather uses this approach. Are you writing your own mediator libraries, or you're using some third-party library which is doing this? Yeah, that's the most popular in the .NET ecosystem, the mediator by Jimmy Bogart, which is very, very good library in my opinion. I forgot to ask also how much of the audience is .NET folks, and what other languages are attending here on the call. I'd like to see if there are people from other technologies, regardless. All right, PHP, we have one. Android, good. .NET and Python, that's awesome. All right, so we have a variety of technologies. .NET only, great, great. So currently, that's good. Yeah, so as I said in the start, this could be applied to any language regardless. So it's on ideological level, it's not an implementation detail. All right, so again, we'll test it how it stands again. How this design stands against the solid principles. Again, the same conditions are applied. How we add new feature, change feature, remove feature. So adding new feature is adding a class which holds the implementation of the new feature. Straightforward. Implementing one of those interfaces, a request, handler, and so on and so forth. Here, this could be a little bit twisted if we consider adding the DTOs and the responses, but that's a different talk. Then changing a feature, find the class which implements it and change it. If we want to expand it, we add, as we've already shown, we add a decorator, or another tool which the current library provides, like middlewares and so on and so forth. Then we have removing feature, deleting a class which implements the feature. That's it. And let's consider again the testing scalability and modularity. The testing, in my opinion, is very easy to test such a class, since it's hold all the necessary things, nothing extra. The interfaces are tight. You are not exposing methods which you won't be using. Don't have to mock unnecessary dependencies. So if you're testing, for example, creating a product which has to be audited, you don't care about caching, for example, since get product by ID is implemented in a whole separate class, nothing to do with the creation of the product. That's what makes it decoupled. It's not tightly related to another functionality of the same entity, which is good. Then scalability. this has a good and bad sides in it, since this could lead to a large number of classes because every functionality is a separate class. It comes with its models, uh, request model, response model, and so on and so forth. But this could be easily handled if you apply a very good folder structure, so you can easily understand what's hold where and navigate to it. But if you're putting everything in one folder, this could become scrolling classes so long that and some classes might be sounding very similar, but they have a little twist in the implementation. So it has to be, we have to be very careful whenever we are architecting this kind of system to think about what would be the folder structure we want to go with. And it also depends on how big the project will grow. And then the modularity, it's hard. So basically everything is modular. You're creating little modules and then you compose a workflow. That's how you can think about it. And basically there are like building blocks which you can buy, you can combine however you find good. And then this is the class diagram. It looks scary. Those things with a little text, they're not that relevant to the whole thing. Those are dependencies injected in the so they're not relevant. So here the meat of it is this I command handler. This represent every class implementing this interface would be doing some mutation. As I said, creation, adding, side effects also, you can say. And the query handler is another interface which basically represents all the functionalities which are pure functions. So you get something from the database, you list, you search, and those actions are considered pure functions since they don't change the state of the system. Basically, they're called idempotent, so you can call them as much as you want, and it's guaranteed that it will return the same answer every time, rather than the other side, which is on the left side. Here, if you execute a function twice, the state of the system won't be the same. Like it might be the same, but it wouldn't be every time. And here I have this same decorator, and those are like my custom implementation of mediator pattern. Here I still have this iProduct service, which the implementation, but this implementation here is just a facade for all the functionalities. That's why I did it this way. I didn't want to break the whole interface and start injecting. For example, we have an existing system which already uses this abstraction, and you can't just go there and remove it and start injecting all different kinds of bits, like for example, create product. For example, this sound controller might need some only create product and list product, and you can go there and remove this and add those, because that would expose us to a lot of work rewriting the whole system. So I've left off this thing here, but now the product service is just a facade which is passing through the execution to the specific command handler or query handler. I open the demo later and go and walk you through the whole thing so you better understand how it's gone. So, and I have a command mediator, query mediator, and other different helper classes, and the repository is the same. That's the dependency. That's pretty much what we'll see on the demo as an end result of our refactoring. So we'll again say what are the pros and the cons of this solution. As I said, easy to maintain, since it's easy to provide new functionalities to such a design. You won't break anything, or at least it's very hard to break, and it will be localized bug, which you can easily find and fix. Very extensible and flexible, composable. This is a big thing, since you can compose those building blocks into more sophisticated workflows, and it's concise, straight to the point. The class is doing what it's supposed to do, not doing a lot of things, adding, modifying, listing, searching, so on and so forth. So when you go to this class, you know what it does, and it has to be doing it. It has to do what it says it's doing. So those are the pros. But as we know in programming, there is no silver bullet. Every design comes with downsides. As I already said, leads to large number of classes. If not managed appropriately, could lead to mess. So a large number of files in the project, and therefore hard to navigate. More complex, since as you saw, there are so many different small classes implementing interfaces. Basically, this is approach which would take more senior developer for solving a problem. It's more complex, but the complexity is benefited by the flexibility provided by the solution. So you're more flexible, easier to maintain your system, it's easier to write test cases, unit tests. And this is the third disadvantage: requires knowledge of specific programming techniques. You have to know basically on ideological level what's going on here. You can blindly start to implement it, but if you're not considering those advantages and disadvantages, you might end up in a not very good position. So this was briefly the whole. Somebody's writing on the chat. Thanks, Radoslav, for joining us and for the props. So this is pretty much the end state of our system, and we will become more flexible, but it will be more complex, as I said. So here we will do a Q&A session, then I'll jump into the demo, and then we'll get back to questions and answers. So does anybody have any questions regarding the solutions, or something they want to ask? Also, at the end, we'll have a feedback form where it will be awesome if you add your feedback about the talk, the presentation, the demos. The presentation and the demo would be added to a follow-up email, so you can see them on your own. Even you can clone the repo and try some things, see how they're done, and so on and so forth. So all materials will be available to you after the presentation, and also the video as well. Yeah, therefore you can ask questions on the feedback form as well, or you can contact me wherever you feel appropriate, pretty much on all social medias sites. And also here are some details of the company, my company email, so on and so forth. All right, so nobody has questions so far. It might means nobody anything, or it's all clear since it's easy stuff. But
that might be also frustrating to ask questions publicly. So we know that. So you will have the chance to ask questions also at the feedback form. We will appreciate that a lot. Yeah, so maybe also after the demo, you will have the chance to ask a question. So please prepare some and let's go directly to demo.
yeah, all right, let's get our hands dirty. All right, we have, is this a good pattern for applications where a lot of things happen? Yes, this, yeah, I understand what you're talking about, background jobs which are working on schedule or something else, or they're triggered by something. In my current project, since it's greenfield project, I get to design those things by myself, so pretty much the whole. But I've been in projects where parts of the systems are done one way and other parts in another, since not we are working like a lot of teams in a particular organization, and every services and every team is making decisions on their service. So I find this approach applicable pretty much everywhere if your task is complex enough. So for small applications, I'd suggest do the entity one, or it wouldn't be even called this way since it's so small that you don't have any specific entities at that point whenever your system is so small. And here, yeah, for also for crons and workers, yeah, for sure, this could be applicable. And one cron could be one use case. It depends on what you're doing, but pretty much in my experience, one cron is one use case. Or yeah, I don't know if that answers the question, but yeah, you can do it. It wouldn't be using the mediator though, since mediator involves bunch of a bunch of different requests, different commands to be involved in order to introduce mediator. You'll probably end up using only the CQS design, which is one thing is one functionality is one use case, and that's it. You have to introduce mediators, which will tell what handler would be executed. That's for workers and crons. And basically, you can look at the workers and crons as in a cloud environment as functions. Didn't matter if it's on whatever cloud provider you're using, AWS or Azure, which are providing, for example, Pandas and Azure functions. Basically, idea there is that one function should be one use case, and basically on that scale, they've invented this serverless and function specific approach to support this use case. So basically, whenever you're composing a serverless application, you'd like to have one of your functions to be one use case. Yeah. Yeah. And all those, like, I'll mention a lot of common logic, which you're mentioning here, like validation, caching, logging, security, localization. All those are called cross-cutting concerns. Uh, we can create another talk on this thing, but basically, you would like those to be like a separate things, like as as the example here with the decorator. Um, it's a separate thing which doesn't pollute the meat of the service. So let me bring that decorator back. So here, the idea here with this decorator, which is auditing, is the same as validation. It, yeah. If there is a huge interest in cross-cutting concerns, you could log that in the feedback form. We might think something about explaining those and how we can handle those. But currently in this situation, I'm handling it. It didn't matter if it's auditing or validation, since the validation code here. And then I put the creation code as if validation passes, and that would be a whole separate uh, cross-cutting concern. Currently, I'm using audit product service, so we have one of those common logics which could spread along the whole system. So you might want to audit some other stuff as well. And basically, for those, we are creating separate how to approach this kind of problems is creating separate class which is called decorator class. We inject the business logic what should be done, and we're covering the validation, for example, in this class, and then we pass through to the class which is executing the business logic. And it's very important here to say that some validation business model, so we have to be very careful in regards to what validations we are doing as a cross-cutting concern and what is a business validation itself, since some validations are part of the business model, since the business is explicitly saying that that's a rule which applies to this business. It's not a common thing, like, for example, if we pass a no instead of some object, which is a whole different story. But as I said, you can write whatever suggestions you want to see in the feedback form, and we can see what we can do about talking about different aspects of programming. So basically, that's how common functionalities are handled in a most elegant way. I mean, the other way would be we are injecting everything here, validator service, auditing service, whatnot, but this will create a burden on our testing and unnecessary dependencies on our classes, since that's not what the business needs to execute. It's something which comes as a the price to make your software more reliable, more easier to troubleshoot, easier to debug, to self-recover if you wish, and so on and so forth. So, or any other questions? I hope I answered those, actually. All right, good. So we've already seen this approach where we have, I'll even close those. These are the two classes which we care about. I'll even close all those here. So we have this interface, and that's the implementation. here stands the business logic. And we usually, because I've seen this so many times, that's why I've created this way, injecting repository, which is the part of the system which persists the data in some data store. We have business logic, whatever we're doing, and then we're persisting the data and so on and so forth. That's the service here, everything in one place. So this is what entity-related service is. Then the second step is how we are applying solid principles step by step to this solution. And then we go to our step 2 of the process. Here we have the same facade class, same interface, as you can see, list, get, create, edit, delete. We have the facade class. But the facade class, as you can see, every functionality has separate interface. So we have a bunch of interfaces. I call the folder product, and that's our first step in the refactoring. And I have iProduct create with method create, iProduct delete with, and so on and so forth. It applies to everything. And we have class which implements each of those interfaces. Then we inject all of those here. And this is basically a pass-through class. Doesn't do anything, just passing through to the class which is responsible for the specific functionality for a product. And that's what I mean by facade, and that's the facade pattern as I know it. You can clearly see here again that we're returning voids, we're returning some models here, so on and so forth. So far, haven't done much, just split the interface to obey the interface segregation principle from solid. We can talk about here single responsibility principle, that every class has single reason to change and so on and so forth. Oh, good. But it's kind of annoying to see all those interfaces being injected here, and it's a lot of boilerplate. So we are making one step further into our refactoring, and then we again have the same facade class in an interface, but here you can see now we have command handlers and query handlers. And what are those? We split our model into commands, which as I said, are the functionalities which change the state of the system, mutate the state. And those are create, delete, edit. In this base folder, I have done the abstractions, and this is the only interface which has to be implemented by all of those. So as you can see, I have create command, create product command handler, which implements iCommand handler. It's injected this and does this. And here, as you can see, it's called final with casting. So we are basically doing command and query separation, but not with the specific types. We're not specifying the types, we're casting the types, which is pain in the butt. This is one step before we get to our end solution, since C# has answer for this. And here I'll show again, we're injecting all of those and how we are using them. So we have create product, so we have create command, product create handle, whatever, and so on and so forth. As I said, this Git repo would be provided to you, so you can clone it, look at it, understand what I'm doing if you haven't while I'm talking. And the query side is basically iQuery handler. It returns object and it has only one method, handle, receives object. And now, since this, I've been doing this talk, I've done this talk a couple of times before, and people at this point start asking why you haven't used generics, and 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 generics is the last thing, the last step of the process, where because our language provides these tools in order this to be strictly typed, and the compiler would tell you what's going on in your solution and what type you have to provide as a parameter, what to expect as a response. So this is the final solution here, where we take the advantage of what the language is giving us on the platform to create generics. And this is basically the final solution here. So I still have commands, queries. The facades are the same. Basically, we have the same interface going from start to end. Since some other stuff in our system might be depending on this interface, that's why I decided to leave it, since it's a refactoring talk, not only to give you theoretical knowledge, but this will be the way I'll approach a system which depends on some entity-related service. I'll leave the interface at the beginning, and then whenever I'm done with all the hard or the heavy lifting behind it, then I might consider rewriting and removing it, because this could lead in a lot of work also. And this is how the implementation looks like. So we have this command handler class, which gets create product command as input parameter, and so on and so forth. You can see the whole picture. We have a query handler. So I forgot to say what's the difference between iCommand handler and iQuery handler. They accept that on a ideological level, the one is mutating the state, the other is requesting data, and it's a pure function. And it's a good thing that we separate the pure functions from impure functions, since pure functions can do harm to a system, rather than the impure, which could harm the system, could get it into an inconsistent state. That's why I split them. In the last solution where I use mediator, it's one interface there for both, and you have to be aware of this, and you can take certain steps in order to separate those into impure and pure functions. Also, I'm not sure how many people are familiar with a functional programming paradigm. I'd like to know if somebody has read about it, has tried it, so on and so forth in the chat, because it's a good topic to talk about. So here the command handler accept command and doesn't give you any result, which is kind of daunting in a way. Some cases here might be different, might be hard to implement, or you have to think about them. They're not trivial to implement. So here we have to consider that it's not returning anything. And I've went to the what CQS really is. So the impure functions doesn't give any results. The pure functions are giving results, and that's to it. And I went all in on this, but I understand that there are drawbacks to this approach here, since it's hard to, for example, if you want to combine all the errors in the model you're passing, it's hard to make it this way. You don't have a way to return anything from here. the only way you can handle this is to use the exceptions, to use exceptions here and catch exceptions, and but that doesn't give you a lot of room to work with. So it's kind of gives you the benefits of knowing that you will be only doing mutations here, but also restrict you in some ways. And here are, as I was showing to the generics, it's basically the same thing, but using generics. So we have command, which is our input parameter. I also annotate those with in and out when, wherever it's applicable. Here also in the iQuery handler. Here we have inquiry out result, where tQuery is iQuery of result. So this is the interface every query, every request object have to implement in order to execute a handler. And that's why I'm saying this approach is a little bit complex, not a little bit, but fairly complex regarding to the entity-related ones, since here we have to have an understanding of generics and all those nitty-gritty stuff in order to start working and understanding what we are doing, since it's easy to copy and paste those from somewhere and use them. But if you don't have an understanding of something, it's worse to use something you don't understand than to use bad approach which you understand, because when you don't understand it, you basically are not prepared for what the results will be. And all right, here we have get, which is this, an implementation of a handler implements this interface. We'll get this as an input parameter. We'll get this as a result. That's to it. And those are the input. That's the input. That's the result object. And that's it. Here is the mediator class, how it looks like. So we have a command processor, which is basically command mediator. That's the implementation. Here I'm using constructor injection of a container, since I didn't want to use activator to get an instance of the command, which is not the best, especially in enterprise solutions, to pass the IOC container here and there. But I'm currently using a console application, so this could be done different way, not this way. You could inject the thing, the command which you want to execute, or whole commands, and then loop over it and see which one is applicable to the command, to this command which is passed, and then execute this one. That would be a more good approach. That's a dirty approach after all, just to present the idea. And this is the query mediator, pretty much the same. And all those should be registered here in this container. And that's the final solution. That's the endpoint where we've obeyed every single principle of the solid and made our design one little bit more flexible. And that's in quotes, since it's way flexible than it was at the start. And here, when we're talking to cross-cutting concerns, how we apply those. So that's the whole work we've done. Is one of the things, one of the benefits we get is the ease of applying cross-cutting concerns. In our case, this is auditing all the mutations. And this could also go well with validations and all of the rest, since I want all of my mutation operations to be able to audit what's going on. Here, this should be a different thing. I want all my mutations to be audited. I'm creating auditing command handler, which is implementing the same interface and getting as a dependency a specific command handler. This could be create, open the commands. This could be any of those. So I can pass to this audit command handler, for example, create product command handler. Then when I execute this handler, first of all, I'm passing the parameters to the initial command handler, which would be this one. This will create a product, and after that, I'm attaching the cross-cutting concern, which is auditing in my case. This will add this activity to whatever store it wants, and then it will continue on since it's not returning anything. Same can go with validation. Here I can also inject the same command handler, but the validation will be done here. And then the command handler will be executed. That's why the decorator pattern is one of my favorite ones, since you don't have to go here and add another service. For example, I audit service, which will be handling the auditing. You basically create another class which would wrap this, and whenever this is executed, it will add it, and that wouldn't pollute any of this business logic, which has to be concise. And yeah, but we can have a whole separate talk on this as well. And that's what it is to it. If you have any questions, you can ask. If not, I'll quickly just go through how a mediator data library in .NET is using this approach, and how I've separated those in commands, queries here, and aspects here. I'm calling it because there is aspect-oriented programming, which is regarding the cross-cutting concerns of your system. But as I said, this could be another talk. And here are my commands for product, and these are the aspects which are applied to those. And you can see audit behavior. The library is providing you a pipeline behavior, which is pretty much decorator, but a little bit different. And this is how it's done here. It's basically, again, creating a separate class, which is your cross-cutting concern. And this is executing the business logic, which is down the pipe. Basically here, they are creating a pipe, not a decorator. So they create a pipe, and up to that pipe, where the last step could be your business logic. And before that could be validation, some security stuff. And after your logic could be caching, could be exception handling, or some other cross-cutting concerns, as in a pipeline, as ASP is doing. In my examples, I'm using decorator. And this is the query side of the system. Again, fairly easy to understand. I even here created the response object and the request object in the same file as the handler, so it's easy to see. But basically, as you can see, I'm repeating myself in every of those, since the business logic here it's not big. The idea is what's interesting, and how the composition of the object is done, how how you decompose a large thing into single tiny pieces and create workflows with those, how you then can put something in front of the before execution, after execution, and how you can arrange them in the decorators. Like I'm not even sure how it's in English, matryoshki. That's a Russian tool, which one is wrapping the other. And this is my approach, whether and the mediator is using a pipeline where you add to a pipe, you have step 1, step 2, step 3, step 4, which might be your business logic, then back around step getting out like step 5, step 6, and so on and so forth. But basically, we are circling around one idea, which is decomposing and creating small things responsible only for one thing and with one reason to change. And here is how they are composed. So first we have the monolithic service. That's whenever you want to compose it in a container, or how you create instance of it. For example, that's the decorator. Here I'm creating a product service, and then inserting in it the repository. Then this is where, when I apply the single responsibility and interface segregation principles. I split everything. As you can see how it will look like to inject all those through the constructor of the product services, which is a facade only here. Then we have CQS basic, which is pretty much the same as this one. Creating the facade and injecting all the services. Then we have with the generics. Here you can see audit command handler with this create, and then inject this command there inside of it. And those are the pure functions, the queries. And then here I'm using simple injector as a IOC container, and how they're registered. Most IOC inversion of control containers have neat ways to handle those cases, how to register such a query handlers and command handlers, so you don't have to register them one by one. For simple injector, for example, it's like you're specifying the type and the assembly, and it will go through the assembly and see whoever class implements this interface, and this is nothing, nothing. So all the implementers with whatever parameters, generic parameters there are, type parameters there are, will be registered. And you don't, and whenever you want to create another feature, it will be automatically injected. You don't have to go to the IOC container, inject it explicitly. And here is how the command handler is injected. Very nice and neat. This is the only 2 lines, only a couple lines of code you need to sort of inject your services. And whenever you want to decorate some of those, this is the syntax you're using. In simple injector, other IOC containers might use a little bit different methods to do that, but pretty much all of those are supporting this kind of stuff. So to implementations of this interface, you apply this command handler. So that's how decorator is used whenever a command handler instance is injected somewhere. And then, as you can see, I'm creating basically the query mediator passing the container, and then a simple application of what's doing. I'll set it on one more time that you get this. You can clone it, you can test it, and it's pretty cool stuff, in my opinion. So that's actually the whole talk for today. Let me get back to the Q&A session. I welcome questions regarding those solutions. Also, I'll appreciate very highly if you use the feedback form. I've added a couple of helpful links here. This is the repo. You receive this presentation. This is a CQS design by Martin Fowler, and command query separation, again, on Wikipedia. And you can read a lot of it. There, even the documents, actually it's invented on 2005 year by Bertrand Meyer. That's a lot of years ago, and it's still applicable to the current state of programming. So those are the useful links, and those are the feedback form and job opportunities here in Ciklum. I appeal you to look at those. We have very good projects in a company to work on. The positions are good. I think everybody would love to work in Ciklum. As I'm judging by my experience, basically, I'm very happy being in part of Ciklum. So if you want to understand how it is, you can enroll in whatever position you feel comfortable and program stack you feel comfortable on. And that's the feedback form.